Time to get started with our tech talks. I am your host, Bill Murphy. I am Bill Murphy. I'm the civil engineer PE on staff for the 4 companies listed above: ASP, Quick Supply, Bowman, and Cascade. We do have over 40 years of experience at most of those companies, and we have now over 12,000 customers, and we have 30-some sales professionals. So if you know your local ASP, Quick, Bowman, or Cascade rep, great. If you don't, reach out to me and I'll introduce you to them. We have a number of CPESs on staff, and we cover a lot more states than even what's shown here on the map, but these are primarily our target markets. ASP covers Illinois, Missouri, Nebraska, Kansas, and Oklahoma. Quick Supply covers Iowa. Bowman Construction Supply, it has 3 locations in Colorado and also serves Wyoming. And then we have our new Cascade Geosynthetics office in Portland, Oregon, and they also do work in Idaho, Washington, and Alaska. We do cover a whole lot of solutions and large warehouses and great trucking ability, and I'll get into that in a little bit. But these are just a few of our categories. We have many more. Erosion and sediment control, our rolled products, we're very well known for those, and our geosynthetics and geogrids. Stormwater management is where I spend most of my time. Green infrastructure and low impact development. We also have hardscapes displays at a number of our locations, and that continues to grow actually. And all of those work hand in hand. We also have waterproofing and bridge at Bowman Construction Supply and architectural division there as well. But there's a whole lot of things that we can get into, but we don't have enough time to cover them in every individual webinar. Contact me or your local rep to learn more. And one of the things I'm very proud of is how clean and organized we are on a regular basis, even in the very busy construction season. Our warehouse crews do a wonderful job taking care of the yards in the warehouse. We have a tremendous amount of inventory readily available, and we can put together some pretty creative shipments so that instead of you having to be responsible for logistics for a whole lot of different companies and a lot of different trucks, we handle that for you. So this will show up again at the end of the presentation. And of course, you can go to the internet. If you go to any one of these websites, they're all interconnected. And if you want to use the regular old-fashioned phone numbers, you can do that. We even have the toll-free numbers listed on our websites. But again, if you already have a relationship with a local rep, reach out to them. So with that, I'm going to hand over the remote controls to our friend and guest speaker here today, my friend Sam Justice. She's a PE, a fellow civil engineer. And Sam's responsible for overseeing project evaluations, managing the engineering activities of Geosystems worldwide partners, and coordinating research and development. She has experience specializing in water resources, stormwater management, rock and soil stabilization. And you can go ahead and click to the next slide if you want, Sam. She's going to cover repair and reduce slope erosion with Presto Geosystems. And she has a geotechnical degree, engineering degree from University of Michigan, and a geological engineering graduate degree from Michigan Technological University. And she's a registered professional engineer. Sam provides technical and project-specific support to consultants, contractors, and distributors for all of the Geosystems products and application areas. I've had the pleasure of traveling with Sam and doing some live presentations at some engineering offices, and we've had her as a guest speaker here with us before. She does an excellent job. And Sam and I just talked this morning about how a lot of our engineering can still be done virtually. In the old days, everyone thought we had to go see every project site to walk it and talk it, and we love doing that. But we can be a lot more efficient, a lot more productive with our time if we just embrace these virtual meetings. And if that leads to an on-site visit someday, so be it. But we can do a whole lot of good engineering up front. With that, I'll hand it over to my friend, Sam. Good afternoon, Sam.
Good afternoon, everybody. I hope that you all are having a good day so far. We do have a lot to get through, so I'm going to move through it kind of quickly. But I do want to just get into our presentation. It's going to be on slope and channel erosion protection using the Geoweb system. So Bill was really nice, gave me a great introduction there. But yeah, I've been with Presto for a little over 3 years now. So I'm going to be a great resource if you do have any sort of technical questions, anything like that. So with that, let's get started. We're going to start with getting a good look at what the Geoweb system is, how it works, how versatile it can be for a wide variety of projects and different types of situations, including some really steep slope applications and high flow situations during channel applications. And then we're also going to look at some of the university accredited research that we've performed with the Geoweb system so that you know that we're not just pulling numbers out of thin air. We actually do back up what we are interested in and what we're trying to talk about here. So we're going to start out with what the description is of the Geoweb 3D soil stabilization system. If you're not familiar with this type of product, we've been doing it for about 40 years. So it is out there. It is not brand new, but it's still new to some people. So the Geoweb system is our version of GeoCell technology, and it consists of two main attributes. The first is going to be the cell or the container size. And the cells come in 3 diameters, small, medium, and large openings, and then cell heights from 3 to 12 inches. So what dimensions you're going to choose are going to depend on your project details and whether you have loading requirements, what your flow situation might be, that sort of thing. We can help you determine which one is going to be the most appropriate for your project and your specific job. There are also 5 section lengths, so how big your panel is, to best fit your project site specifically. So the ultrasonically welded seam, which is highlighted here, is where all of the connecting points are. And it's going to be very important to the function of a geocell. The stronger the seam strength, the better the performance of the geocell. A strong seam allows for the use of heavier infill materials, steeper and taller slopes, and better overall lifetime performance. The Geoweb product is produced using a high-quality virgin high-density polyethylene, HDPE. It's a plastic resin, and it's consistently strong at the welds for each cell junction, while maintaining semi-rigid ductile properties within the cell wall. This getting a bit into the chemistry. It's not too important for you, but just sort of keep in mind that if you have too stiff of a cell wall, it can lead to overstressing of these seams and potential for cell rupture and project failure. Definitely want to avoid that. So our cells don't use any sort of exotic fillers or polymers, which reduce that weld strength. Some other geocells on the market do. I'm not going to name any names, but there are some lower quality products out there that I just want you to try and avoid, because I don't want your projects to fail because of something internal with the geocell. So just keep that in mind. So the second main property of how a geocell works is going to be the infill material of the cell. So there are 3 main infill types that can be used with the Geoweb system, depending on the type of protection that you're looking for. So that's going to be topsoil with vegetation, aggregates and granular soils, and then concrete. In most cases, this does allow you to use on-site salvaged or site one materials. So if you're doing excavating, you can reuse that material. So you don't necessarily need to import fill if what you have on site is going to work. So all 3 types can be used for slope and channel protection. When they're used in channels, concrete is going to be your best option if you do have very high flows that are anticipated. Otherwise, aesthetics is kind of going to be the driving factor in which material you choose, whether you want to see grass, whether you want to see stone, that sort of thing. So we do offer a complete system solution for erosion control products. The system components are all of the supporting accessories that help the Geoweb panels protect your slope and channel. So I've got a simplified diagram here where we're going to show each of the different system components and how they interact with the Geoweb panels to form that system. So basically what you have is you have your regular channel slope, and then you're going to put down a geosynthetic layer. This could be a geotextile, a geomembrane liner, geogrid, anything that's sort of a 2D product. And then you're going to put the Geoweb panels in place. And I do want you to note how the Geoweb panels have a horizontal turn near or at the crest of the slope. So this is really important for anchoring the Geoweb panels and then also for erosion control. We're going to talk more about that. So we have 2 different options for anchoring. The first is going to be using either stakes or face anchors. So these are placed along the slope face and at the crest. And the number of those stakes that you're going to need is going to be project dependent. The other option is to use tendons and some sort of crest anchorage system, usually a dead man pipe, perhaps concrete anchors, earth or rock anchors, whatever may be best for your site. And then you have the Geoweb material, Geoweb panels filled with your infill material. And if you're doing vegetation, we do recommend something like a biodegradable erosion control blanket until that vegetation becomes established. Then we also have a diagram of a channel system. It's going to be essentially the same thing. But I do want to stress when I say channel, I'm talking about protecting an entire area, which could be the full width of your channel. So the bottom plus the side slopes. It could just be the bottom, or it could just be the slopes. If you had an embankment, maybe you're looking at a dam structure, something like that. So channel is a very broad term for us. So it is going to be basically the same concept where you're going to put that geosynthetic liner, geotextile, something like that down over your native subgrade. Then the Geoweb panels, fill them in with your material, and then you're going to have some sort of anchorage. Again, you're going to have anchors along the slope face. You're going to use tendons, have some sort of crest anchorage like that. So different options available. We are always happy to help you figure out which one is going to be most appropriate for your product or for your project, excuse me. So definitely feel free to reach out to us and we can help you determine what's going to be the best option. So most channel projects are going to be very similar to a slope project. So feel free to think of them kind of interchangeably. I'll say slope and channel, but they basically are the same concept. And there are two ways of building up the Geoweb protection system. The first is to use a single layer system where the Geoweb panels are laid directly on the channel bottom and side slopes and then filled in with their material, kind of like how we just saw in the diagram. So this is going to be good for areas where the slopes are less than 45 degrees. So relatively shallow, you're not looking at anything super steep. So as long as there's room for the footprint of your channel or your slope, this is probably the most efficient way to protect against erosion. However, if space is limited, or if the project area is going up against existing structures, like homes or roadways that you can see in these photos, a multi-layer system can be designed. And so in this case, the side slopes need to be pretty near vertical, and the Geoweb panels can be stacked on top of one another to create a retaining wall structure. And that can happen on one or both sides of the channel. And Geoweb retaining walls can withstand the same types of velocities and shear stresses as the single layer system. And then they're still flexible enough to handle curves, changes in grade, anything like that. So it's a great way to create a deep channel or have those really steep side slopes up to 80 degrees. So there's a lot of options for mixing and matching how the Geoweb panels are going to be placed, allowing for a single design solution, even with really complex project sites. Getting into retaining walls is a whole nother webinar, so we don't have too much time to talk about it today. But if you do have questions, I'm always happy to answer. And we have some more information on our website at prestogeo.com. Okay, so if we think back to the diagrams, there was one thing that wasn't shown, and that's going to be the connection device between the individual Geoweb panels. So the ATRA key is what we call it, and it's the first component for a completely integrated system, connecting individual panels of Geoweb into a single web that covers your entire project area. It allows for faster installation of Geoweb and is going to last the lifetime of the project, ensuring that the slope is protected and that the Geoweb system isn't going to fail under your anticipated loads. The specific engineering values of the ATRA key are going to ensure that the system holds up to loading over time without corrosion that you often see with metal staples or failure from underperforming cable tie systems. And so then now we can look at some of the anchorage options that we talked about. So if the Geoweb panels are laid basically completely flat, anchorage is usually not needed because gravity is going to do all the work. However, as your slope angle increases and you start, running into to gravity hurting you rather than helping you, you are going to need to have some sort of anchorage system. For shallow slopes, so think 2 horizontal to 1 vertical, so about 26 degrees, stake anchorage is usually going to be sufficient. So we have 2 options for stakes. One is made of standard steel rebar, and then one is made of the high density polyethylene, HDPE, which is shown in the photo here. So if you're in a saline environment, it's like along a coastline, the HDPE speed stake is actually going to be a lifesaver compared to corrosion prone steel. And the stakes can be driven either by hand, just a hammer, or power drill if you're looking for easier installation. Then we can get into steeper slopes, so greater than that 2 to 1, but also in areas where your native soil may be highly erodible, or if you're over a surface that can't be punctured. So if you have a geomembrane liner, we can do a tendon anchorage system. And then we have a specialized clip, you can see it in the left photo, called the Atra tendon clip, which transfers the load from your infill material to the tendons and then up to that crest anchorage. So we're going to talk a lot about that crest anchorage today, so definitely keep that in mind. One more thing to say, the Atra tendon clip is something that is a proprietary thing to us. No one else has this type of load transfer device for their system. So they're using basically things that aren't as strong, things that aren't designed specifically to work with geocells to try and hold the tendons in place. And so it's, 1, a lot harder to install, but 2, it's not as great in terms of long-term performance. So at Presto Geosystems, we've done a lot of work and a lot of research to create this whole system solution where we know the product and all of the accessories are going to be the right thing for the project that we recommend them for. So we do stand behind our work, and we really, we want to give you the best options that are available. Okay, so basically with that overview of the Geoweb system, let's dig a little deeper into some of the capabilities and functions of each of the infill types that we had talked about. And we can start with the vegetated infill, so using topsoil and then having a grass surface. So one of the best things about the Geoweb system is how much trust we have in how the system works. That's because we have 40 years of experience and research backing up what we are saying. So a huge series of tests were completed through Colorado State University in Fort Collins under the direction of Dr. Chris Thornton. CSU is considered one of the top hydraulic research facilities in the world, and it's pretty unique since it's located underneath the Horseshoe Reservoir and has a couple 100 feet of static head and can achieve extremely high velocities and shear stresses in their flumes. So this is probably the best place to test for any sort
It's
of
amazing.
hydraulic testing.
I know you didn't ask me to chime in, but I want to for 2 things. One, I love the Atra key, the Atra tendon, and the tendon clips. We've done a lot of projects, some with, some without, and all the ones we did it without, I feel like we regretted it. We love those products, not because that's something to sell, but because they really, really work exactly as designed. But I'm also close personal friends with Dr. Chris Thornton, and I've been out to CSU, and they do amazing work out there. I love it. So I'm excited about these. Thanks, Sam.
Yeah. So vegetated infill testing was performed with 2 different objectives in mind. The first was the ability to withstand high velocities and shear stresses, which are the main components you're going to think about when you're withstanding water flow. And then that second objective was that we wanted to compare the performance of the topsoil filled Geoweb system versus riprap and other conventional solutions such as erosion control blankets and turf reinforcement mats. So the testing consisted of 6-inch deep Geoweb panels filled with topsoil and then vegetated with grass, which is probably our most recommended cross section for this type of project. So this was a great research test. And the grass was able to grow about 6 inches before they did any of the testing. So real world conditions. A total of 10 1-hour-long tests were performed with varying conditions, including flow rate and bed slope angle. And the testing was done in accordance with ASTM standards. So that covers both soil loss through scour and blade density. The ASTM standard considers a successful test when you have less than a ½ inch of topsoil loss and at least 300 blades of grass per square foot. So the blade density is important since it doesn't help if all of your soil stays in place, but your grass washes away. You're just left with a muddy, ugly looking channel. So trying to avoid that. And vegetated channels hold up really well, even against turbulent flow, such as around corners or near rough terrain. Most people would think that a vegetated channel can't actually handle that much water, but when it's all properly confined within the Geoweb system, along with a surface protection system, we can achieve velocities of 30 feet per second and shear stresses of 16 pounds per square foot, excuse me. And so here's one of those tests. You can see it being performed in the outdoor flume. You can't even see the vegetation under all of the water that they've run through here. So it's, I think, about 6 to 8 inches of water over top of the filled Geoweb system in that photo. So actually very turbulent for being in just a standard square flume. And so here's just a quick comparison of some of the pretty impressive results, if I say so myself. So you can see that the Geoweb filled with topsoil can handle velocities of a little over 29 feet per second compared to the 12-inch riprap, whoop, I went too far, which is only about 14 feet per second. And then it even outperforms the use of a turf reinforcement mat by itself. And it basically doubles the acceptable velocity and shear stress. So the key takeaway is that the topsoil filled Geoweb system provides about twice the protection as 12-inch riprap and doubles the performance from a standard TRM or ECB. So actually really great results. So here's a typical application using the Geoweb product along the side of a highway compared to a conventional riprap system. The riprap system looks unfinished and is going to need a lot of maintenance after every storm event to ensure that there hasn't been significant loss of material. With the Geoweb system, you get a nice green lawn and you can be assured that it's still going to look this good even after a big storm event. Much less maintenance and much less worry. And the system works great for road embankments, no matter the weather. So this was a vegetated slope over an unstable soil slope in an active gold mine in Canada. So got pretty cold. It had both varying slope lengths and face angles, all within one system. So Toronto is definitely that cold weather environment, and the Geoweb system stands up really well to snow, frost heave, ice, anything that nature can throw at it. An access road is actually going to be built above the slope where that excavator is currently sitting. So the slope had to be stable enough to support that expected road traffic as well as hold the soil in place. And when used as a road embankment, the Geoweb system protects the slope from water runoff and sloughing with no loss of vegetation. And here we can see some space constraints at the toe of a slope in the form of another access road so that the slope couldn't really be regraded to a gentler, less erosive angle. It had to stay at this pretty steep one. So a nice feature of the Geoweb system is shown in our after photo on the right, where there's a guardrail installed at the crest and a fence installed along at the toe. There's not really a limit on this sort of infrastructure being installed near or even on the Geoweb panels, which is great in tight spaces like this one. So this was a slope alongside a roadway that shows a common problem that can be solved with the Geoweb system. Erosion and washout of soil slopes onto road surfaces is a problem almost everywhere. And covering the slope with the Geoweb system and then filling in with topsoil allows for a clean vegetated slope without that concern of having to constantly go back and replace the soil after rain events. And typically we do recommend some sort of surface protection, such as hydroseeding, be used over the Geoweb panels until that vegetation has a chance to grow. So just give that grass a little bit of time. So stabilizing the slopes and embankments near buildings is a good way to utilize the Geoweb system. Here you can see it's a relatively shallow slope, but there's a lot of variability on the slope face that can sometimes cause erosion problems. Immediately behind the cameraman is a building for the University of Iowa, and it's a really common project that we see, just needing some basic surface protection on an existing slope within the constraints of a project site. The Geoweb system is fast, easy, and really effective at this job. Throw some Flexterra growth medium over the filled Geoweb panels, and soon you have a nice green slope that won't allow significant runoff or soil to flow into the parking garage. And when the grass is fully grown in, you can't see the Geoweb panels at all. It just looks like a natural slope that people can walk on if needed, because you know somebody's cutting through there to get to their car a little bit faster. So roadway embankments are not the only option for the Geoweb system. You can place the panels along a shoreline to help against erosion due to water movement or wave action. So this project was on a man-made lake in Kansas. Water is constantly flowing, gently, but moving nonetheless towards an outfall structure. And the shoreline was getting pretty severely eroded, eating into people's backyards and making it unsafe to walk on. So the Geoweb panels are placed both above and below the average water line in this type of project. The panels need to go below that water line to ensure that they don't get lifted up due to wave action, and essentially to protect that entire shoreline all the way to your stable lake bed. The area does not have to be dewatered to do this type of installation, so you don't have to worry about putting in any sort of temporary cofferdam or anything. The Geoweb panels will float initially, but eventually they're going to be staked down to be held in place. And once the infill material is there, the system is not going to move. In this photo, it's pretty obvious to see where the Geoweb panels are, but over time, the divide between new and old grass becomes a lot less noticeable. And using a soil and a grass type that's local in your area, maybe even using that salvaged material from the excavation process, will help with blending in so you don't have such a stark dividing line. But now you can walk along the lakeshore without fear of it sinking in, and the shoreline is going to be protected against erosion for years to come. And one last thing for vegetated infill, I just want to highlight that the Geoweb system along channel side slopes is definitely an option. Notice how the panels just cover the sides, not the channel bottom itself. So the Geoweb panels will allow for vegetation growth up both the embankments, which normally aren't going to be underwater, so grass is going to go just fine. And notice that there is the bright yellow liner that's there below the panels. So they decided to use the tendon anchorage system, so without causing any of that damage to the liner. And so even with that liner underneath, the vegetation can still grow because of the soil held within the cells of the Geoweb panels. So now this stormwater overflow channel, if it does become flooded, the side slopes are protected and the channel can do its job. Maintenance on these type of systems, this is actually really easy. Lawn mowing can happen if you have regular grass. Just use your standard lawn mower, walk behind and riding varieties, totally fine. You're not going to damage the Geoweb panels by doing that. Or you can pick a flowering or tall grass vegetation and no maintenance is needed to begin with. So it really is what we call a place it and forget it type of system. Okay, so that was a lot on vegetated infill. Hope you were able to keep up. But let's move on to aggregate or a stone infill next. So the crushed aggregate testing at CSU was both indoor and outdoor. The main objective of the aggregate testing was to determine how much the Geoweb 3D confinement can aid in reducing the riprap stone size. The indoor testing consisted of varying flow rates and bed slopes, along with 2 different aggregate stone sizes. So we looked to see how well the aggregate stayed in place during the tests to determine what rock size would prevent washout. We ended up maxing out the indoor flume and had to go to the outdoor flume to allow for increased flow rates. And so we got flow rates up to 125 cubic feet per second, along with 2 different aggregate sizes. So again, you can see it's pretty turbulent flow going through here. And again, looking to see how that aggregate stays in place. Obviously, the system doesn't work if the water can just pick up the stones and move them somewhere else. You want them to be held by the Geoweb panels. So the results are pretty impressive, working on a steep slope and allowing some pretty high velocities and shear stresses. Although if we remember back to the vegetated system, the allowable velocities there were 30 feet per second, and now we're down to 18. So it is actually a little bit less. A vegetated system can actually withstand those higher flows and stresses, which may seem counterintuitive until you think about the strength of a properly rooted grass system compared to a single stone within the aggregate. So it makes a little more sense. And remember, the main objective was to determine the reduction in riprap stone size due to the Geoweb system. Also keep in mind, vegetated channels can only withstand water flow on an intermittent basis. Otherwise, the grass is just going to die because it's drowned. If you do have continuous flow, aggregate infill might be the better option, even though it can handle a slightly lower velocity. So different things to think about. So Dr. Thornton put together a design tool that we use. It's based on a entirely too complicated regression analysis, but so it's how we can compare the reduction in crushed aggregate with the Geoweb system compared to conventional riprap. The tool is based on all of the testing data, and it allows us to predict the rock loss and the rock size based on specific hydraulic conditions. So what it comes down to is that we can recommend the appropriate cell depth and rock size for individual projects so that you can be confident that the aggregate that's placed isn't going to wash away. So you can see that there's some results showing using a 2-inch crushed aggregate confined within a 6-inch deep Geoweb panel. And the tool compares the Geoweb solution to both the US Army Corps of Engineers and the ABT Johnson design formulas, which you can see are at 16 inches and 10 inches respectively. So for this job, the reduction was pretty huge, 2 inches compared to 16. It's pretty great. So this was a project for the Minnesota DOT, which used the Geoweb system to help stabilize the surface around a bridge abutment, and then also along railroad tracks and crossings. The flexible nature of the Geoweb panels means that it's easy to contour to the slope face and around obstacles such as piles or abutments. So with this system in place, water erosion is prevented around the abutments, reducing lifetime maintenance costs. And the entire project was actually a mixture of topsoil and vegetation in some areas and aggregate in the others. Aggregate usually being used below the bridges where the vegetation would have been, difficult to establish. That's always kind of in shade, not really getting a lot of sun. So you have a nice ability to mix infill types to best fit your project needs. This was another project for just outside of a brand new housing development in Arizona. So heavy runoff from intense storms were leading to erosion and flooding to the adjacent subdivisions. And several existing embankments and storm channels had already failed under 100-year storm events. Repair time was critical to reduce flooding to the homes and prevent that runoff. And it was about a mile-long channel, and it was routed with detention ponds and into the natural drainage areas. So the channel area was cleared of any sort of existing vegetation or boulders, anything that might have gotten in the way. And then it was just had the native sand subgrade, graded and compacted. So to prevent the infill loss, a non-woven geotextile was put underneath the Geoweb panels. It's pretty common to just use a really lightweight, think like a 4 or 6 ounce non-woven geotextile. The channel here is pretty wide and had some pretty shallow side slopes. I think they were 3 to 1 in this area. And the flow rate was going to be both intermittent and slow. So the anchorage consisted of using our Atras stake anchors. So using those stake anchors along the face rather than using tendons. So one of the really nice things about using the Geoweb system is that it allows for in-place adjustments depending on what you need. Here you can see the Geoweb cell depth was actually reduced from 8 inches all the way down to 4. And that's because the second half of the channel from the main inlet was subjected to really reduced flow rates and shear stresses. Because of this, less protection is required, so a shallower Geoweb panel was used. Saved on cost and installation time while still meeting the performance requirements. So this is really only possible due to the strength of our Atra key, so that connection device between panels. If you had used staples or something like a zip tie, it just doesn't provide enough strength and those panels are going to end up separating over time. So you have an area of potential failure in the middle of your channel.
I can vouch for that. Sorry to chime in again, but that's exactly what I've seen in the past was other things used were always regretted. Thanks.
So the Geoweb panels themselves are really flexible and they can be easily cut in the field to allow for existing infrastructure such as these pipe penetrations. So here you can see the drainage pipes that were going into a nearby drainage pond. It's really simple to complete these field cuts with the Geoweb panels. You can just use some snips, maybe a Sawzall, something really small, handy that your contractors probably already have. So you don't need any specialized equipment to make these sorts of in-place changes. So the areas right below drainage weirs, such as these, should be built up a little more robustly since this is the area with the highest potential for stone washout due to the turbulence of water coming out of the pipes. So just something to keep in mind. And then also just want to point out installation rates. It's actually pretty quick. Once this crew who had never done Geoweb installations before kind of got their hands on it, they were able to get about 2,000 square feet of Geoweb sections per hour in the ground with a 4-man crew. So it does not take a whole lot of effort to do this type of installation. So the infill for this project was actually waste rock from a nearby quarry. So it's not the greatest quality, but that's really okay. When you're using the Geoweb system, the rock doesn't have to have any requirements other than a general size and that you want it to be angular. So try and avoid things like pea gravel. So your money can be saved on material and hauling costs. The only infill that we do really want to avoid, like I said, is going to be that pea gravel, maybe something like river rock, anything that's really rounded because it's not going to lock up and it's going to have that potential to have a little more scour. So just something to keep in mind. So another advantage of using the Geoweb system is that you can actually drive directly on these systems once the stone is in place. So they can be used as access roads for construction to try and help limit the amount of extra installation space and time that you may need. So you can sort of fill in ahead of the trucks in front of you. And the Geoweb system can support those heavy vehicle loads, basically no issue. So, and then here's the installation. Once it's done, you can see the channel flow going over the Geoweb panels and then out into a natural drainage system. So with the aggregate protection system, there's going to be little to no maintenance required since that aggregate's going to be confined within the panels. You don't need to replace it. You don't need to come out and keep checking to make sure it hasn't washed away. And the channel itself is then built large enough to accommodate large storms without overtopping. So again, a place it and forget it type of system, which is obviously really beneficial. Okay, so our last main infill type, which is concrete for impervious hard armor protection. So again, testing was performed at CSU for the concrete filled channels. We ran a couple tests. Oh, I've done it again. Apologize for that. So basically, there is no requirement for the concrete once it's poured into the Geoweb panels. You don't have to have any sort of internal reinforcement such as rebar, fiber, anything like that. The Geoweb panels themselves are the reinforcement. So the Geoweb system actually maxed out the flume at CSU at about 36 feet per second. And there was no degradation to the Geoweb panels, the concrete infill, or even the soil underneath the panels. So it's really going to be an excellent system for protecting your channels, dam faces, anywhere that's going to see really high velocities. And 36 feet per second is just as fast as the channel flume could handle. It's obviously capable of going much, much higher. So don't let the 36 feet per second stop you. And I do want to say the Geoweb system is the only geosynthetic, including things like articulating concrete blocks, TRMs, ECBs, ever to max out the test flume at CSU. So we are very confident that this is going to work for even the most challenging projects. So now we don't typically see concrete slopes in areas where there's not a threat of high velocity water movement, but it does happen. So this was a project, again, protecting a bridge abutment from erosion. The slope was really quite steep. It was actually greater than 45 degrees. I think it was around 55 degrees for this specific project. So there aren't actually many options available for this type of protection, but it's no problem for Geoweb. So you can see that the bridge was built up and then the underpass slope was graded, and then the Geoweb panels were allowed to be installed. So obviously there's no room for a crest anchor trench here, which is something that we saw in all the other locations. We saw it in the diagrams way back in the beginning. So usually there is some sort of trench or horizontal turnout at the crest to help anchor the Geoweb panels. Couldn't happen here because there's a bridge abutment in the way. So you do have some other options, such as using concrete anchors, or if there had been a little more space, they might have been able to do earth anchors, which don't need that large anchor trench. So there are options if you know you're in very confined space project environments. So because of the steepness of the slope, the concrete had to be pumped into the location, and then the Geoweb panels were filled in by hand. The Geoweb panels should be filled up to the top of your cell and then screed flush so that you ensure a consistent concrete depth. There's really no point in overfilling the Geoweb panels here, since gravity would just cause slumping before the concrete could set properly. But with the concrete that's held in the cells, there's going to be no slumping, and it can all set up quite nicely. You see that in the after photo there. So this was definitely an interesting application to have a concrete slope like this. But if it's required for whatever regulatory reasons, or if it's just the best fit for your project needs, using the Geoweb system as your formwork is a great way to place concrete in otherwise impossible locations. So now for a more common application type, the concrete filled Geoweb is best used when there is going to be water flow. So here was a channel project that takes water runoff from a train intermodal yard. The Geoweb system replaced a design that had 6 inches of reinforced concrete channels and 4 inches of grout bag slope protection. So we were actually a value engineered solution due to cost overruns. So we had the 6-inch reinforced concrete brought down to the Geoweb system, saving a couple $1 million, but also more importantly, speeding up construction time and allowing the yard to be in service much quicker than was initially planned. So the side slopes of this channel used 3-inch deep Geoweb anchored with stakes because the slopes were relatively short and flat. And then the bottom of the channel used 4-inch Geoweb. So again, you have that flexible option to have different depths. And that was done so that the bottom of the channel could support some vehicle loads. So best way to create the right project for your needs. So as I said, the Geoweb panels act as the formwork for the concrete, so you don't need to build any additional forms. And that's really nice because it can be tricky to build forms on slopes. And it's always going to extend your project times when you have to have that additional formwork created. So using the GeoWeb panels is a nice shortcut. So generally the concrete is going to be poured from the top to the bottom, and then the cells hold it in place, prevent it from slumping. And you do get a nice, even, consistent thickness when you're using the GeoWeb panels. So the GeoWeb panels, oh, sorry, repeating myself. You do need to worry about pore water pressure buildup with any sort of concrete structure. That includes with GeoWeb panels. You don't want any of that water to build up underneath, which could cause uplift and damage your concrete. So it's pretty easy with the GeoWeb system to drill in weep holes or have them pre-installed before the concrete is poured to relieve that pore water pressure buildup. So it's really important that you do that so that you get a nice looking project like this. This one was more than 1 million square feet of GeoWeb, and it saved the railroad a significant amount of money and installation time. So we can go from really small, road embankment protection to some of these massive projects. The GeoWeb system is going to be able to handle all of it. So this last section I'm going to go through really quickly. It's just something I want to highlight because I think it's really interesting. And these are some unique conditions, including very, very steep slopes and high flow velocity situations. So this was a project along the Pan American Highway in Peru, where the slope of each one of these terraces was actually 1/4 to 1, so a little greater than 75 degrees, which is insane. So these terraces were actually hand compacted at this angle. They were man-made, created to be like this. And it required a lot of tendons and a lot of anchorage to help hold the GeoWeb system in place. But it's definitely doable. And you get some interesting pictures like this of guys rappelling down these very steep slope angles to install the GeoWeb panels. And I just thought it was a really cool sort of photo. You see there's 4 terraces of these really steep angles, fully vegetated in a way that vegetation would never grow. Usually once you get greater than about a 45-degree angle, vegetation starts having problems getting hold and getting a good root system. So using the GeoWeb system gives that vegetation a little bit of extra boost to help hold it in place, apparently even on incredibly steep slope angles. And then the other thing I want to point out is for very high flow velocity situations, you can add things like energy dissipators to a channel. Generally, these are only going to be installed in concrete channels because you do have that very high flow. But they can be as low tech as just throwing some boulders in the middle of the channel, or you can go to nicely formed patterned dissipators like they're doing in this photo. So they can be placed on the very steep slopes, same as the GeoWeb panels. And if you utilize a tiered system like this, it can help limit the height and the angle of those channels, make it a little more doable while still containing and directing your water to your downslope collection area. So in this particular case, the dissipators were actually formed off-site and then installed after the concrete of the channel itself had cured by doweling into the concrete and then providing an epoxy bonding agent around the bottom edges of each of the dissipators. So a couple different ways of doing that if you are interested. The number of dissipators, the size of them, spacing, all of that is going to be dependent on what type of flows you're anticipating in your channel conditions. There's no one right way to include energy dissipators, but it's something that myself and the rest of the engineering team here at Presto Geosystems has experience in, and we can help you determine what is going to be most appropriate for your site if you do need something like this. So just keep in mind, if you do need to go from very high flow velocities into essentially no flow at the bottom of your channel, this is one way to do it, and the GeoWeb system can accommodate it, no problem. So some kind of cool photos. But basically, I'm going to end it here so we have time for questions. Geoweb system is great for slopes and channels with great flexibility of design, variety of infill needs for your projects. Do topsoil, that crushed aggregate, concrete, whatever is going to work best. So it's going to provide protection against surface erosion due to high flow velocities, gravity, anything like that. And we do have all of our systems backed by 40 years of experience and research and testing, and we stand by all of these numbers. So here we do offer just some quick summaries of the research if you are interested and want to know a little bit more about how that testing was completed at CSU. This is something that we can offer. It can also be included in bid packages and the like to sort of be a little extra boost for why the Geoweb system might be most appropriate for your project. And then we do offer free project design evaluations. So this is something that we offer through our internal engineering team, including myself. So this is how we can help you determine what size and depth of Geoweb panel might be most appropriate, your anchorage requirements, anything like that. It's all a free service that we offer. It's through our website. You can fill out the form, attach things like, geotechnical reports, plan drawings if you have them, CAD files, anything like that. And then we can help you get a design evaluation where we can give you some cross sections, CAD details. We would include the research summaries if you had a channel project, all of that sort of thing to help you in your bid process for any sort of individual project you may have. So that's my presentation. Thank you so much for listening. I got kind of quick there at the end. My contact information is on the screen, and then Bill and all of the people through ASP, Bowman, Quick Supply, and Cascade have my information as well. And we work together really closely to help you with the design evaluations and giving you budget estimates and everything like that. So
great job, Sam.
Over to Bill. Yes.
You're a pro, right on time. That is, I wish you could do all of them every week, or everybody else would learn from you how to do it. That's awesome. And you even handled a couple of my interruptions. Thanks for letting me do that. I avoided a third interruption, and that was to say I dig the photos with partially concrete fill down at the bottom of a channel, and then either aggregate or vegetated fill above. I think it's so cool because that's the kind of design value that you can add up front, is to say, you only need to fill the concrete up to the maximum flow velocity or wherever the high shear stress is, and then the rest of it could either be aggregate or vegetation, ideally if you can get vegetation to grow.
Exactly.
So we had a couple people use the Q&A, and Don he attends almost all of our webinars and is excellent at questions, and he asks quite a few questions all at once. So if you take a drink, I'm going to ask these to you and have you help me answer them live.
Go for it.
What material are the tendons, and do they come in various diameters?
So yes, the tendons are either made of polyester or Kevlar, and that's because concrete will basically eat away and degrade polyester. So if you do have a concrete solution that needs tendons, we recommend our Kevlar options. And we do have a couple different options for both polyester and Kevlar, depending on the amount of strength that's needed, and those come in some different diameters, different strengths. So there's a couple different tendon options to best fit your needs. And
that leads right into a couple good answer. A couple of his other questions are the tendons delivered in rolls or straight lengths, and what's the strength of the tendons? So getting really engineered specific. If you have a minute, you can at least partially answer that. I know that it's specific to the project, but how do you quickly respond to that?
Yeah. So the tendons do come on rolls. Usually you get, I think, 1,000 linear feet on a roll. And so the strength of them does depend on which one you choose, and which one you choose is going to say how much strength your project needs. We typically recommend, unless you're using concrete, in which case you'll use Kevlar, but we typically recommend our polyester tendons because they're a bit stronger. If you have any knowledge of tendons, it's going to be TP, which is tendon polyester, and then 93, which is around 2,000 pounds per foot, or TP 225, which is around 5,100 pounds per feet. And that 5,100 is one of the strongest tendons on the market, and it's good for almost every application. So.
Wow, beefy. And he does ask a question, and I'm going to change the question a little bit. Like he asks, are there holes in the GeoWeb to accept the tendon installation? And the answer is absolutely yes. And how are they anchored to the blocking? And they're tied off at the top at the blocking, correct?
Yeah, so there are, we call them eye slots, but there are very specific holes that are created during the manufacturing process of the GeoWeb panels that you would run the tendons through. And then they are attached with the Atra tendon clip, which is one of the things I pointed out way back in the beginning, but it's our load transfer device. And that ties to the tendon, and that then strings the tendon all the way up to your crest anchorage, where you either tie it around a dead man pipe and then bury it in a trench, or you tie it to a concrete anchor, earth anchor, anything like that. Usually they have an eye hook, and you just do a good strong knot to that eye hook and you're good to go.
Awesome. And I'm going to skip one question because I'm going to get to him directly, and because we're going to run out of time here. When you're doing the concrete infill, how do we handle cold joints like doweling, expansion joints, and sealants and things like that?
So you don't actually need to have a lot of that sort of extra work when you're doing concrete with a GeoWeb system, because the concrete is already slightly separated when it's put within each one of the GeoWeb cells. So once it's within that cell, you have the thin plastic between basically sections of the concrete, and that gives the concrete room for expansion and contraction if needed. And so that actually allows you to get away with not having expansion joints or needing to do a lot of the cold weather concreting. If you are interested in doing that anyway, you can. You can basically run cuts through the filled in GeoWeb panels. That gets pretty project specific. So if you do have specific questions about that, I recommend you either ask myself or go to your local distributor through Bill, and we can help you determine what the best option is. But it is a little bit less needed when used with the GeoWeb system.
That's awesome. Thank you. And Kevin's question is specific to MODot, but we're right at the 1 hour. So do you have any specific MODot projects that already have bid tabs? Has it been used with federal aid projects?
Yes.
Not, we can answer. Okay. We can answer via email if you want to get more in depth.
Yeah. If you do have very specific questions, I do recommend reaching out. I'd be happy to get in detail with you. But we do a lot of federal projects. We do a lot of projects with the U.S. Army Corps, with the DOT, state DOTs, all of that. So that's definitely something that we have familiarity with and are capable of helping you navigate some of those bid requirements when using the GeoWeb system.
Awesome job, Sam. I've captured those questions. So what we'll do is when we send out the Survey Monkey and we gather questions from people, we get some general questions, we will be able to answer those back. So when we send out the PDH certificates that we'll send out from our company, we'll have Sam help us type written answers to those questions. So everybody who attended today will get those written questions and answers along with the PDH certificate. So once again, thanks, Sam, and everybody else, please tune in next week. We're going to have somebody else on March 24th as well. So we're going to fill every Wednesday through March and probably through April. And by then we're going to be so busy with construction, we'll probably put our series on hold. But thanks again, Sam, for joining us. You did an awesome job.
Thank you. I hope everyone has a wonderful day.
Thanks. Take care, everybody.